Hello everyone, our group is Namcorn and Korish. We will talk about the ozone layer and CFCs. See all the beautiful sceneries outside. The reason that they don't all burn down is because of the ozone layer. The ozone layer sits in the stratosphere, which is about 10 to 50 kilometers altitude. Ozone is a gas made up of 3 oxygen atoms, or O3. Ozone is created when the kind of oxygen we breathe, O2, is split apart by sunlight into single oxygen atoms. Single oxygen atoms can rejoin to make O2, or they can join with O2 molecules to make ozone, O3. So when these UV rays hit the ozone layer, O3 molecules absorb the energy from the UV rays, splitting it into O2 and O molecules. However, these would rejoin back into O3, repeating the cycle. The ozone layer absorbs a whopping 97 to 99% of the sun's medium-frequency ultraviolet light, or UVB. If left untreated, these rays can cause massive increase in skin cancer, damage to vision, and destruction of the immune system. Nonetheless, the ozone layer is facing a great threat: CFCs. Chlorofluorocarbons, CFCs, are man-made chemicals that were widely used in a variety of industries until the late 20th century. They are composed of carbon, chlorine, and fluorine atoms. CFCs were once considered miracle molecules because of their many desirable properties. They are non-toxic, non-flammable, and stable at room temperature. This is why they are used in the refrigerator to remove heat, and in aerosol cans to create a propelling effect. CFCs aren't supposed to get released into the atmosphere, but improper disposal of these products can lead to leakage. Because they are so durable and stable, when they get released in the atmosphere, they rise up to the stratosphere. Here, they get broken apart by the UV rays, releasing a chlorine atom. The chlorine atom reacts with an ozone, O3, molecule, splitting it into an oxygen molecule, O2, and a chlorine monoxide, ClO, molecule. Here's the key point: the chlorine atom doesn't stay used up. The chlorine monoxide, ClO, molecule can then react with another oxygen atom, O, regenerating a chlorine atom, Cl, and releasing another oxygen molecule, O2. This freed chlorine atom can then go on to destroy another ozone molecule, perpetuating a vicious cycle. One chlorine atom can destroy up to 10,000 O3 molecules. There is a severe depletion of the ozone layer over Antarctica that occurs annually during the southern hemisphere's spring, September to November. This phenomenon was first discovered in the 1980s and has since been a subject of considerable scientific concern. During the peak depletion periods, 1980 to 2000, ozone levels over Antarctica could drop to as much as 70% compared to normal values. Thanks to the Montreal Protocol in 1987, the use of CFCs has been limited. The ozone layer still gets depleted every year, but the rate of depletion has been stabilized since. It may take decades to reverse the damage done to the ozone layer, but we are on the right track to save our planet. Thank you for watching.